All right, so this is going to be our walkthrough for our derivatives of logarithmic functions assignment. So these are all just going to be using our rules for natural log of u or log base a of u. We may combine a couple other little rules in there, but it'll always be a chain rule problem here. So if our function is the natural log of 7x, that's the natural log of u, where u is equal to 7x. And of course, we know the rule for the derivative of natural log, right? The derivative of the natural log of x is 1 over x. So if we want the derivative of natural log u with respect to u, that should be just 1 over u. And then we'll multiply that by our du dx, which is 7. So our answer here should end up being just 7. We'll write dy dx here. dy dx is 7 over u, 7 over 7x, which is, of course, going to simplify down to just 1 over x. And of course, I think I showed this in class, but you can always rewrite this using log rules. You could say f of x is equal to natural log 7 plus natural log x. And because the natural log of 7 is a constant, its derivative is 0, which means that we just need the derivative of ln x, which is 1 over x. So either way you do it is perfectly fine. You'll get the exact same answer both ways. We can also break this one down using log rules, but I think I'm just going to go right ahead and do it using the chain rule. So this is natural log u, where u is equal to 3x cubed. So our derivative should be 1 over u times the derivative of 3x cubed, which is 9x squared. Right? So we should be multiplying these two things together, which ought to give us 9x squared over 3x cubed. And if we simplify that down, we should just get 3 over x. For our third one here, this is, again, natural log of u, where u is equal to x squared minus 5x plus 1. So we're again going to have 1 over u for our derivative of natural log u, and we're going to have our du dx, which is going to be 2x minus 5. So our final answer here should be 2x minus 5 over u, where u was x squared minus 5x plus 1. For number 4 here, we've got the natural log of the secant of x. Well, again, that's going to be natural log of u with u equal to secant of x. So we'll take the derivative of natural log u, which is 1 over u, and we'll take the derivative of secant x, which is secant x tangent x. And when we put this all together, we end up with secant x tangent x divided by u, or divided by secant x, which should, of course, cancel out and just become tangent of x. For our next one here, we've got natural log of sine squared x. So this one is going to be a chain rule within a chain rule. We have natural log u, we have y is equal to natural log u, where u is equal to sine squared of x. Well, the natural log u part is really straightforward, right? That's just going to be 1 over u. But the sine squared x part, that's like u is equal to v squared, where v is sine x, because remember that sine squared x is the same as the sine of x being squared, right? So the inner function, v, is sine, and then our outer function is the squared, the v squared. So we need to multiply this by our derivative of v squared, which is 2v, and then we need to multiply by our derivative of sine x, which is cosine of x. So what we end up with here is just a 2 times our v, which is sine x, times our cosine x in the numerator, And then in our denominator, we've just got our u, which is sine squared of x. And so we can simplify that out. That's just 2 cosine x over sine x, or if you prefer, 2 cotangent x. For number 6 here, we've got the natural log of another function, natural log of 3 sine x squared. So we can rewrite this as y equals the natural log of u, where u is equal to 3 sine of x squared. Right? The natural log u part should be straightforward enough. We've done, now this is the 6th one of these, 1 over u. But for u equals 3 sine x squared, that's u is equal to 3 sine v, where v is x squared. That's another chain rule. So this is chain rule within the chain rule. So we've got the 1 over u. Now we multiply by the derivative of u, which is going to be 3 cosine v. Then we're going to multiply by the derivative of v, which is going to be 2x. And so as we put all of this here together, we should end up with a 6x cosine of x squared in our numerator. And our denominator is just going to have u, which is 3 sine of x squared. And if we simplify that down, the 6 over the 3 should become 2. And we have cosine of x squared over sine of x squared. And we also have the x there, right, with the x in front. We have 2x, and then we have cotangent of x squared, right? Because cosine x squared over sine x squared should be cotangent of x squared. All right, for number 7 here, we've got log base 2 of x to the 5th power. Now, our rule for log base a of x, right, the derivative of that derivative is just 1 over x ln of a. And so we've got 2 options here. One is for us to use the chain rule. So if we choose to use the chain rule, we'll do that first, and then we'll see the other method as well. We can call this log base 2 of u, where u is x to the 5th. So we need to take the derivative of log base 2 of u, which is 1 over u times the natural log of 2, right, according to that rule that we've got over there. And then multiply that by the derivative of x to the 5th, which is 5x to the 4th, which ends up giving us 5x to the 4th over x to the 5th, because that's u, natural log 2. Or in the end, just 5 over x ln 2 when you cancel the x to the 4th over the x to the 5th. But another option would have been, and this option I think is even actually a little bit easier, and you're welcome to do this for these simple ones, is we have a rule for logarithms, right, that says if you have an exponent within the logarithm, you can pull it out in front as a coefficient. So now we don't even need to use the chain rule. We just keep the constant out in front, right? Our derivative, or we'll write our derivative here. Our constant stays, and then it just becomes the derivative of log base 2 of x. Well, that's 1 over x ln 2. So we end up with 5 over x ln 2, either way you look at it. So either method's fine. For the more complicated ones, though, like log base 5 of cosine x, you can't do any log rules to make that any simpler. So we'll just use the chain rule. This is log base 5 of u with u equal to cosine of x. And so we can do the derivative of log base 5 of u, right, dy du, is going to equal 1 over u ln 5, and du dx is going to equal negative sine of x. And so we can just multiply those together, saying dy dx is negative sine x over cosine x ln 5, or if you prefer, I would probably normally write it this way, negative tangent x divided by the natural log of 5, but either one's really fine. All right, just 2 more to go here. We've got the log of 4x cubed plus cotangent x. So you need to remember that when there's no base written, that means common log, right? That's like having log base 10 here, right? So this is like log base 10. We call it common log. So this is the log base 10 of u, where u is equal to 4x cubed plus cotangent of x. So we'll just do our same rule. We'll do 1 over u ln 10, and we'll multiply it by the derivative of our 4x cubed plus cotangent x. Well, 4x cubed becomes 12x squared when we take its derivative, and then the derivative of cotangent is minus cosecant squared. So our final answer here is going to be 12x squared minus cosecant squared x, all divided by u, so 4x cubed plus cotangent x times the natural log of 10. And our last one here is the natural log of the natural log of x. So this one, we have the natural log of u, where u is the natural log of x. And so if we take the derivatives of each of these, right, y equals ln u, that derivative becomes 1 over u, and the derivative of ln x becomes 1 over x. So effectively, we have 1 over u times x. Well, u is ln x, so this is 1 over x ln of x. And that's it for our walkthrough on the basic derivatives of logarithmic functions homework. You're going to see some more homework assignments that have some more complicated functions involving logarithms, and that's it for this one.